I was asked to give a talk about web interface frameworks. Unlike back-end technology that's hidden from view, web frameworks appear to change rapidly, as if driven by the whim of developers. While this is true to an extent, change is more a response to changes in the technology used to consume the web. Let me take you back to 2006. It was the year Twitter and Facebook launched, and Google bought YouTube. I was living in Bath and driving a Mazda Bongo. I owned a cutting-edge mobile phone, the Sony Ericsson K750i. It had a great camera, played music, and I could check my email. However, its ability to view web pages was pitiful. Internet browsing was something I did at a desk. I worked as a Java developer at a software company. I still took any opportunity to work on Lotus Domino web projects, as I could be a lot more productive than if working on massive, monolithic, model-driven Java projects full of EJBs. Unknown to me, on the other side of the country, work had started on EmbleBank Webbin. The choice to base it on Java server faces was sound. JSF had been around for 2 years and was a J2EE standard technology. JSF suited developers. It abstracted away unfamiliar technologies such as HTML, CSS, and JavaScript. It used the stateless HTTP protocol and maintained state on the server, generating the web pages for display in the browser. This was the norm for web applications at the time. Either you had the server do all the work and deliver HTML and CSS to the browser, or you used a plugin like Flash-based Adobe Flex or Java applets to create rich browser applications. For a couple of years, the AJAX technique had been emerging. Instead of storing state for each user on the server, AJAX applications track the state in the browser. Rather than generating a new page for each server request, JavaScript in the browser would request only the data needed from the server via XML requests. The JavaScript would then modify the existing page dynamically in the browser to incorporate the new data. Google Mail in 2004 was an early example of this technique, followed by Google Maps in 2005. As the servers served the minimum data needed instead of the whole page, they did a lot less work. As they were not storing state, sharing that state between servers was not an issue, so there could be many servers. It was possible to support large number of users by scaling horizontally with small, cheap servers rather than vertically scaling using large, expensive application servers. AJAX was a technique I've been using with my Lotus Domino applications, as unlike Java technologies like JSF, it was much more common to work with JavaScript. The problem was, at the time, browser support with JavaScript varied greatly. Just because something worked perfectly in Internet Explorer did not mean it would work in Firefox. JavaScript was okay for scripting menus on web pages, but it was not well suited for large applications, not least because it was difficult to test and painful to debug. Google wanted to create a tool that allowed their Java developers to write JavaScript web applications. This is where Google Web Toolkit came from. The aim was to abstract away browser differences, hide away the JavaScript, HTML, and CSS like JSF did, and allow testing and debugging of code with existing Java tools. Gwt cross-compiled Java code to JavaScript, creating a different version optimized for each browser. This made it possible to have complex functionality in the browser without having to use Flash, applets, or struggle with JavaScript. Elsewhere, web developers were seeing opportunity of writing browser applications with JavaScript as a first-class language, but feeling the pain when writing complex code. A few months after Gwt was released, jQuery, written by John Wiesig, came out. It too aimed to solve the cross-browser compatibility problems of JavaScript, but by taming JavaScript itself rather than extracting it away. The jQuery JavaScript library provided the tools for working with different browsers and Ajax from JavaScript. In 2007, the landscape changed. The iPhone was released. With its big screen, Wi-Fi connectivity and Safari browsing, the internet from a phone became tolerable, albeit fiddly. The iPhone supported JavaScript, but it did not support applets or Flash. For a web application to work on an iPhone, it had to be limited to HTML, CSS, and JavaScript. In 2008, Android was released by Google, creating even more demand for mobile web browsing and apps. At the time, I was using GWT to build rich web applications for planning and monitoring Wi-Fi router deployments on Google Maps. There were few alternatives to GWT for this sort of application. Even though it was designed for the desktop, I was amazed to see it on the screen of the iPhone for the first time. I then went on to apply what I learnt to other web applications. By 2010, the iPad had been released. With its large screen, browsing the web was a pleasant experience. There was also great demand for native apps, and they got their data from web services. Google Chrome was available for desktop and mobile, and a lot of work had gone into making its JavaScript engine fast. At that time, Gwt, which could produce applications that could run on a desktop, a phone, or tablet, seemed a very good bet, while Adobe Flex and applets fell by the wayside. Adobe donated Flex to the open source community in 2011. It was also in 2010 that work started on SRA Webbing at ENA. Gwt was chosen as the web technology. This again was a strong choice at the time. Gwt was at version 2, the ecosystem was mature, and there was an active community. The major browsers all supported a plugin that allowed developers to debug their Java code while running the JavaScript in their browsers. This made debugging a relatively painless experience. However, Gwt was still a set of tools, not a full framework. It had no option or recommendations on how code should be structured, and it didn't have a pretty set of UI components. While third-party projects tried to fill the gaps, there was not much guidance for developers, and it was easy to run into trouble with large applications. In October 2010, Google released AngularJS. Unlike Gwt, it was a full framework with model view controller implementation and was very prescriptive about how applications should be structured. Unlike JSF or Gwt, AngularJS did not disconnect developers from HTML, CSS and JavaScript. JavaScript was now a first-class language, and AngularJS embraced RESTful web services. Debugging was possible through Google Chrome's developer tools. It was possible to write significant browser-based applications in JavaScript. In the following years, Google's focus moved away from Gwt and to Dart, a language that cross-compiled to JavaScript, AngularJS, and Android. JavaScript engines in browsers became highly optimized. REST services that could serve both browser and mobile apps became widespread. HTML5 features removed the need for Flash. JavaScript as the language for web applications made more sense. In 2013, Google completely transferred control of Gwt to the open source community and effectively stopped working on it, just as Adobe had done with Flex 2 years earlier. In 2014, we were still using Gwt for SRA Webbing. We were using an older version because our servers were stuck on Java 6. The application had become complex and development was painful. The browser plugins that enabled us to debug Java code when running the application in the browser were no longer supported and stopped working. We had to instead recompile Java to JavaScript after each change, and on older machines this could take 20 minutes. The development experience was so frustrating, I started learning Android in my spare time to make me feel that at least I was making some progress somewhere. We got out of this rut though. We moved to version 2.6 of Gwt, optimizing the compilation, and got much needed new machines. Gwt development became tolerable again. In 2005, I was asked to develop the Checklist Editor, a new project in Gwt. My approach was different from SRA webbing. I favoured plain Java so I could test using JUnit and make the Gwt UI a thin layer on top. I wrote a command line client before I wrote the Gwt UI. This let me test I had the business logic working and forced me to make the UI lightweight. I used the latest 2.7 version of Gwt with SuperDev mode. This allowed me to debug the Java code in the browser without needing the discontinued browser plugin. I applied architectural patterns I had learnt from Android to structure my Gwt code. And I chose Bootstrap UI components to get around Gwt's lack of built-in widgets. I found this a much easier way of working, and I was pleased with the results. In October last year, after no updates for 2 years, the community released Gwt 2.8 with support for Java 8 and the latest browsers. For me, it is still possible to productively write an effective web application in Gwt. If I was to start a new Gwt project today, I would follow the approach I took with the checklist editor with a few changes. My UI code would be event-driven, inspired by React. My server-side would be a robust REST service, not Gwt's proprietary RPC mechanism. The REST API would encapsulate as much business logic as possible, and state would be restricted to the client. By using RESTful services like this, I would make testing of the service side easier. I would also be making it reusable with different UI technologies. When the next UI technology comes along, which it will, the service will still work, so have a much longer potential lifetime. Only the lightweight UI would need to be rewritten. The world has moved on since 2010, so for someone starting a new project now, not considering alternatives to Gwt would be a mistake. We are not Google. We don't have the same problems as Google. We don't have millions of users or have submitters on smartphones and tablets. We are affected by the decisions the like of Google make, as we share the same ecosystem. When Chrome dropped Java applet support, this affected our users. When Google stopped supporting Gwt, it affected our development. We can't stay still even if we wanted to, because the ecosystem will move forward regardless. 6 months ago, Angular 2 was released. Angular 2, or just Angular, is Google's complete rewrite of AngularJS. Announced in 2014, it has been anticipated while a multitude of alternatives such as Facebook React have emerged and been adopted by developers. For me, it is attractive as it echoes many of the concepts I have learnt in Gwt and Android. It also has a level of documentation and community support that Gwt could only have dreamed of. So is it a good idea to adopt Angular 2? Effectively, I already have, or at least I have adopted the style of development. My architecture, my UI framework, my RESTful web services would be similar if I was writing in Gwt 2.8 or if I was writing in Angular 2. The main difference would be I would be using Java to write code instead of JavaScript. Actually, I wouldn't be using JavaScript. I would be using TypeScript, a version of JavaScript that supports static typing. Errors are picked up at compile time, not runtime, one of the main advantages of using Java. JavaScript has moved a lot closer to Java with TypeScript. The code I write would be cross-compiled into optimized JavaScript. This all sounds very familiar. If I did choose to make the move to JavaScript, I would not be alone. Last week, the results of Stack Overflow survey of 64,000 developers came out. 3/4 of developers identified as web developers. For a 5th year, JavaScript was the most popular programming language, with Java at number 3. AngularJS was by far the most used web framework, with React second and Gwt not listed. TypeScript, surprisingly, topped the table of best paid technologies in the UK, with Java at number 5. In the battle for dominance of web development, JavaScript has won, for now. We are not going back to JSF and EJBs of 2006. There were enough people willing to engage with HTML, CSS, JavaScript and make it work. Abstracting web technologies to let Java developers continue build front ends is no longer necessary. In fact, JavaScript has crept onto the server-side development too, with Node.js currently the most popular server-side framework. Web development is not going anywhere. JavaScript is not going anywhere soon. Angular looks a very sound option for the next couple of years, until the next big change makes it obsolete too. As front-end developers, we will always need to keep an eye on the next promising framework to replace our aging one.